So dispersion is the last topic that I have to talk about as far as light goes. And this is a unique feature with light because it only happens with certain materials. So it's a property of a transparent material where what we call the index of refraction varies with wavelength. Basically, what we mean here is that when the light enters these types of transparent materials, the bending of the wavelengths of visible light is different for each part of the visible wavelengths. So you can see in this picture here, the white light comes in and there's refraction, as we would expect, that bending because we're going from air to a solid. But in this case, the red bends a little bit and the blue or the violet bends a lot compared to it. And it actually is going to bend twice. It's going to bend once when it goes in, and then it bends again when it goes out and spreads out those frequencies or wavelengths. So what you end up getting is a big spread of the visible light when it comes out of this material. And this is because that what we call index of refraction is different for every wavelength. So it's only in specific materials. Not everything will do this, but some materials will actually have these different bends, these different refractions for the different wavelengths, like red, orange, and so on. You may have noticed this with things like prisms. Diamonds will also do this too because they have the ability to have these different index of refractions, different bending of the light for the different wavelengths. Violet, as you can see, like with blue, violet is going to refract the most, and red is going to refract the least. And then everybody in between is in their order. So red refracts the least, then orange refracts a little more, then yellow, and so on. So what do we care? Well, this is how rainbows are made. This was one of the coolest things for me to learn when I started learning physics. A lot of physics I wasn't very interested in, but when they started teaching this, I was like, that is so cool! Because rainbows are made by physics. And while some people are like, well, that ruins the magic, to me, this makes rainbows even cooler because they're just amazing that they even are existing because of how this works. So how does it happen? Well, you can see here we've got a water droplet, and water droplets work like prisms. So the sunlight goes into the water droplet and you get your first refraction, your first bending, because you go from air to water. Then it reflects off the back of the water droplet because it's shiny. And so it reflects and then bounces forward and then refracts again. So it spreads out even more. And that's how we end up getting our rainbow. So we get our nice spread out rainbow showing us all of the different colors of the visible spectrum. The thing is in order for this to work, the sun has to be behind you. This is why you don't get rainbows on any rainy day and just anywhere. It has to be specific conditions. You do have to have water droplets in the air, and the sun has to be behind you in order for it to work, like you can see in this picture up here, because the sun has to come in, hit the water droplets, and then bounce back towards you. Each drop disperses all of the wavelengths. So as you can see in this picture, all of the wavelengths come out as that rainbow ray, but only one will hit your eye from any given water droplet. And so that's what this one up here is showing you. So only this one is going to show you red, only this one will show you violet, and so on. So this is why the rainbow moves when you move, because those water droplets are all showing you it, but as you move up and down, left and right, you're seeing the rainbow from a new set of water droplets, because they're all showing it to you, but they're all pointing at different angles and levels. So then how do we get double rainbows? Because I'm hoping that all of you have seen a double rainbow before. And this is caused because of extra reflections in the raindrops. So instead of just bouncing once, the light reflects again and then comes out the other side. So if I come back over here, instead of refracting here, it reflects and comes out this way. So it doesn't happen in all of them, but it happens in enough of them when you're just lucky enough. And so you get two rainbows. And so this is the main rainbow. So you can tell because it looks like it's in the right order. So red down into the purples, the blues and purples. The second rainbow is always going to be dimmer and reversed. And this is because of that second reflection. And the second reflection flips the colors back over. And because it reflected again, it loses energy. And so that's why it's not going to be quite as bright. But you can see the double rainbow, the red is facing the red, and so on. So then the question is, can you ever find the end of the rainbow? And the answer is no. I know, it's a bummer. But the reason why they are the shape they are is they actually are technically a circle. So you can't find the end of the rainbow because the rainbow always is going to be in front of you, and it always moves. So if you move, it moves to the point where if the sun's no longer behind you, the rainbow will be gone. And so you can't find the end of the rainbow. I'm sorry. But they are a spectacular version of physics. And for anyone who knows the joke, yes, the answer for what is a rainbow, it's 42. So, so the angle of a rainbow, if you look at this diagram, it's 42 degrees between when it goes in and when it comes out. But the answer to everything in the universe is 42, according to one of my favorite books. So that wraps up light, and that actually wraps up our physics chapter. So let me know if you have any questions.